Hello, students. Well, we just finished the solubility lab, and now we need to do some calculations to find out what your unknown is. So the purpose of these calculations is to determine the solubility of an unknown at different temperatures. Then by plotting a graph of solubility versus temperature at several points, the graph can be used to compare to known graphs of solubility versus temperature, like these graphs here. So you'll be given some graphs like this, and when you look at them, your graph should match up to one of these lines. This is what you did, the KNO3, and you'll be given one of these other unknowns to do, and hopefully your graph will match up to one of those. So to do the calculations, we have to start with some data, and that's 5 grams of potassium nitrate that was in the test tube, and my first addition of water was 6 milliliters, and I found the saturation temperature, the temperature of flushing, you remember that term flushing, was 55 degrees Celsius. And then we added a little more water, 0.6 milliliters, got it to dissolve, and then again watched the temperature cool until it crystallized, this time at 51 degrees Celsius. And then finally we added a little bit more water, and we were at 7.5 milliliters total. We got it all to dissolve, and then as we cooled it, the crystallization or flushing occurred at 44 degrees. So how are we going to plot these points on our graph? So the calculations go like this. Since we want to know how, whoops, good thing I have 2 pencils. Since we want to know how many grams of solute dissolve in every 100 grams of H2O, we want to know what that X is, that's our solubility. We're going to compare that to what we did in the lab, and that was, we had 5 grams of KNO3 in 6 milliliters, which is 6 grams of H2O. So now we need to find what X is. How much would dissolve if there was 100 grams of H2O? Because that's how our graphs are done. Concentrations in grams of salt per 100 grams of water. And right here in this one, concentration, grams per 100 grams H2O. So we're going to cross multiply and divide, and when we do that, 5 times 100 is 500, then divided by 6, and that gives us 83.3 grams of potassium nitrate would dissolve in 100 grams of water at 55 degrees Celsius. So I go to my graph, and so I'm going to go to my graph, and I'm going to find 55 degrees Celsius, that's right here, and I'm going to follow that up until I get to 83 grams, and that's right here. So there's my first spot right there. Make that a little bigger. Okay, and then the next calculation is X grams, how much solute will dissolve in 100 grams of H2O. In this case, we had, again, 5 grams of KNO3 in, this time, 6.6 grams of H2O. And again, if I cross multiply and divide, I get 500 divided by 6.6 equals 76.7 grams of solute. And so now I'm going to go back to my graph, and I'm going to do, this time this was at 51 degrees Celsius. So now I'm going to go to 51 degrees. Here's 50, about 51, about right there. So I'm going to follow that up. And right there is my point at 76.7. And I'm going to do that one more time. 500 divided by 6.6 equals, sorry, 75.7, so that's 76 degrees. that's 75.7. So about 76 degrees, and there we are right there. So I can put my other point in. And then we're going to do one more calculation. Maybe you'll get 4 or 5 points. In this case, we only did 3 points. The last one is X grams of solute per 100 grams of H2O. How much would that be? In this case, we had 5 grams of KNO3 per 7.5 grams of H2O. And when I cross multiply and divide, I get 500 divided by 7.5, and that equals 66.7 grams would dissolve in 100 grams of H2O. And this is at 44 degrees. So now I go to 44. Here we are at 40, 50, 45, about just on the inside of this line here. We'll follow that up right there, and I'm at 66.7. And I put in my next line. Now, if we continue doing this at lower temperatures, we would find that our graph would do something like that. And if we compare it to this graph here, we can see that at, let's see, the first point was at 55 degrees Celsius. So here's 50, here's 55. And if we follow that up, and we had 83, that's right about there. Okay, so that's pretty close. And the next one we had was 76 at 51, 76 at 51, that's somewhere near there. And again, if we keep plotting, we see that, yeah, this matches up pretty nice with what we have. Maybe my first dot could be over a little bit right there, if I'm kind of lining those up. So right there, that first dot maybe is in between these two, but as we plot a few more dots, we'll see that those dots will follow along this line, even though they might be off a little bit, rather than following along this line here. So there you go. That's how you determine your saturation points. You're at each temperature, and then you plot that. And then hopefully if you've done good work, when you come into the lab the day after, you'll be given a piece of paper very similar to this, and you'll be asked to look at these graphs and compare it to your graph to come up with your unknown. There you go.